Alrighty, so today we're going to be having a look at scatter plots. So the point of a scatter plot is it's a visual representation of data. Now, note, it's really useful for bivariate data because we have two things to measure. The other useful thing is that it's really useful when we have two numerical things to look at. So in this case, we're going to be looking with things that have two numerical things. So what some numerical things we record? Well, we could record something like the height or the weight, but we could also record other things like maybe your age, your hand size, maybe your income, maybe the rain pouring down. So there's lots of different things that we could measure that will give us a number. So this is what this graph's really useful. And there's going to be three things we're going to be looking for in terms of any sort of scatter plot. And they come down to trend, direction, trend or direction, form, and strength. And one of our best tools to use in terms of working out these three things is the scatter plot. For trend direction, there's only really three options. Either it's positive trend, meaning it's sort of in a line and it's going up. There's no trend, which just means it's flat, or it's negative trend. Alright, so positive trends should look hopefully something like that. Negative trend should hopefully look something like that. And no trend would probably look something more like this, where it's neither going up nor down. In terms of form, there's really only two things to say. Is it linear or non-linear? Alrighty, so linear graph would probably look something like this. It's not a perfect straight line, but it's a pretty good straight line. Whereas non-linear might look like this. That looks like a quadratic. But there's lots of other different non-linear shapes. It could be an exponential, or it could even be something with the waves, something like that. Okay? So there's lots of different types of non-linear graphs. But for linear, we're looking for something that's straight line. And for strength, we have a few different descriptors. There's strong, moderate, weak, or no association or no correlation. Okay, and we're going to talk more about these later when we talk about R, but in the end we can kind of get a good idea of what our strength might be by just looking at it, but to get a better sense we're probably going to need to go through and actually calculate our R or our R squared value. But anyway, let's have a look at it. So constructing a scatter plot from this data. So we've got two data sets. We need to decide which is our X variable and which is our Y variable. So does height affect weight or does weight affect height? Well, in my mind, if you're taller, you're more likely to probably be a little bit heavier. Okay? Now it's not guaranteed. Obviously, you know, some people are quite thin, but I imagine taller people should be a little bit heavier than shorter people. However, your weight, I don't think it affects your height. You can't keep eating cheeseburgers and at some point you grow 10 centimeters. That just doesn't work. So we can think about it in terms of our two terms, our explanatory variable and our response variable. So I'm saying that height explains the weight, or weight responds to the change in height. Okay, so my X variable, my explanatory variable, and my Y variable, my response variable. So now I can set up my axes. Alrighty, so always make sure your explanatory variable goes on the x-axis and your response variable goes on your y-axis. Alrighty, so let's have a look at my heights. My shortest height I've got is 50 and my biggest height is 180. So I need to make sure that on my x-axis I've got all the numbers between 50 and 180 going up, some nice numbers. So you can see I managed to fit all of those numbers in just like that. And I can do the same thing for the weights. The smallest weight is 20 and the largest weight is 95. So I just need to make sure I can fit all of those numbers in. Alrighty, so there's my y-axis from 0 to 100. You'll notice on my x-axis I skipped 0 to 50 and just started at 50, whereas on my y-axis I decided not to do that. Alrighty, so now I can just start plotting each of these points. So the first point is going to be at 140 along here, and is going to be 60 above. So that's going to be this point right here, and I can get rid of all my scaffolding. Alrighty, so I can tick that one off, and I can do my next one. 160 along here, and it's going to be 75. Alrighty, and I'm just going to keep repeating that until I've got all my points done. Alrighty, so I can double check that I've plotted enough points. There should be 1, 2, 3, 4, 5, 6, 7, 8, and there should be 1, 2, 3, 4, 5, 6, 7, 8. So you can kind of just quickly double check that you've got enough. So what can we now say about our graph? Well, in terms of its trend, is it going up, down, or flat? Well, it's going up, so we'd say that's positive. In terms of the form, is it a straight line or not? Well, I'd say it is a straight line, so therefore it's linear. And in terms of the strength, how spread out is the data? Well, I'd say the data is pretty tightly packed together, so we'd say it's a strong association. Although, we're going to talk about this more later, it's hard to actually call strength until we can actually look at an R value to be certain. But these are the three things we can kind of look at from a graph. So how can we put that into a sentence? Alrighty. Well, there is a strong positive linear association between height and weight. But let me just focus in on one in particular. Let's talk about the positive part. Well, positive means that as height increases, so does weight. Alrighty, so there we go. That's an idea of how we can use a scatter graph or a scatter plot to actually get a fair decent chunk of information as opposed to just looking at a table. Alrighty, I'll see you in the next one. Goodbye.